In modular arithmetic, if a and b are integers and m is a positive integer, then a is congruent to b modulo m. If m divides a minus b, this is the very important basic relation of between the numbers m, a and b. Here, if a is congruent to b mod m, it means m divides a minus b, or m divides a for the remainder b, and if we refresh this, then m divides a minus b. A mod m is equal to b mod m. If they are not congruent, then a is not congruent to b mod m. These 5 important points and notations will be properly used in the problems. Here, by example, you can see if a is 17 congruent to 5 modulo 6. So 17 is congruent to 5 mod 6, as 6 divides 17 minus 5, they are congruent. And for the next example, 24 is congruent to 14 modulo 6. It means 24 is congruent to 14 mod 6, as 6 does not divide 24 minus 14, so which is equal to 10, so they are not congruent. The spiral visualization of mod, here you can see, as in the example shown, the modulo 5 arithmetic. This is for 5, and the points are starting from 0, and here you can see 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, and so on. So here we can see we have the points on the spiral path, like here 1, 6, 11, 16, 21, same here 2, 7, 12, 17, 22, same here 0, 3, 8, 13, 18, same here 4, 9, 14, 19, same here 0, 5, 10, 15, and 20. So here we can use this concept that for the modulo 5 arithmetic, this is congruent to 1 mod 5, this is congruent to 2 mod 5, this is congruent to 3 mod 5, this is congruent to 4 mod 5, and this is congruent to 0 mod 5. It means 5 divides 20 for the remainder 0, 5 divides 15 for the remainder 0, 5 divides 10 for the remainder 0, and 5 divides 0 for the remainder 0. Same here, 5 divides 21 for the remainder 1, 5 divides 16 for the remainder 1, 5 divides 6 for the remainder, and so on. Same here, 5 divides 22 for the remainder 2, 5 divides 17 for the remainder 2, 5 divides 12 for the remainder 2, 5 divides 7 for the remainder 2, 5 divides 2 for the remainder 2, and so on. Same here, 5 divides 18 for the remainder 3, 5 divides 13 for the remainder 3, 5 divides 8 for the remainder 3, 5 divides 3 for the remainder 3, 5 divides 0 for the remainder 5 divides 3 for the remainder 3. Same here, 5 divides 19 for the remainder 4, 5 divides 14 for the remainder 4, 5 divides 9 for the remainder 4, 5 divides 4 for the remainder 4. So here, by the spiral path, we can do experiment for the proper, a different kind of visualization for the understanding of the modulo 5 arithmetic.